Myself, I'm Keshan from CSC Section B. My topic is on keywords in Python. What is Python? Python is a popular programming language. It was created by Guido van Rossum and released in 1991. It supports multiple programming paradigms, including structured, object-oriented, and functional programming. Python 2.0 was released in 2000 and introduced new features such as list comprehensions, cycle detecting, garbage collection, reference counting, and Unicode support. Python 3.0, released in 2008, was a major revision that is not completely backward compatible with the earlier versions. Python 2 was discontinued with version 2.7.18 in 2020. Python keywords and introduction. Every programming language has special reserved words or keywords that have specific meanings and restrictions around how they should be used. Python is no different. Python keywords are the fundamental building blocks of any Python program. In this article, you will find a basic introduction to all Python keywords along with their resources that will be helpful for learning more about each keyword. Python keywords. Python keywords are special reserved words that have specific meanings and purpose and can't be used for anything but those specific purposes. These keywords are always available. You will never have to import them into your code. Python keywords are different from Python's built-in functions and types. The built-in functions and types are also always available, but they aren't as restrictive as the keywords in their usage. An example of something you can't do with Python keywords is assign something to them. If you try, then you will get syntax error. If you won't get a syntax error if you try to assign something to a built-in function or type, but it still isn't a good idea. For a more in-depth explanation of ways keywords can be misused. The keywords: false, await, else, import, pass, none, break, except, in, rise, true, class, finally, is, return, and continue, for, lambda, try, as, def, from, non-local, while, assert, delete, global, not, with, async, elif, if, or yield. These are the Python keywords. How to identify Python keywords? The list of Python keywords has changed over time. For example, the await and async keywords weren't added until Python 3.7. Also, both print and exec where keywords in Python 2.7 have been turned into built-in functions in Python 3+ and no longer appear in the list of keywords. In the sections below, you will learn several ways to know or find out which words are keywords in Python. Use an IDE with syntax highlighting. There are a lot of good Python IDEs out there. All of them will highlight keywords to differentiate them from other words in your code. This will help you quickly identify Python keywords while you are programming so you don't use them incorrectly. Use code in REPL to check keywords. In the Python repo, there are a number of ways you can identify valid Python keywords and learn more about them. Python help keywords. Here a list of a Python keywords. Enter any keyword to get more help. False, none, true, and, as, asset, async, await, break, class, continue, def, del, elif, else, except, finally, for, from, global, if, import, in, is, lambda, non-local, not, or, pass, rise, return, try, while, with, yield. These are the keywords in Python. First, help, pass, the pass statement. Pass statement equals to pass. Pass is a null operation. When it is executed, nothing happens. It is useful as a placeholder when a statement is required syntactically, but no code needs to be executed. For example, def f of args pass, a function that does not that does nothing yet. Class C pass a class with no methods. Python also provides a keyword module for working with Python keywords in a programmatic way. The keyword module in Python provides two helpful members for dealing with keywords. KW list provides a list of all Python keywords for a version of Python you are running. Each keyword provides a handy way to determine if a string is also a keyword. To get a list of all the keywords in the version of Python you are running, and to quickly determine how many keywords are defined, use keyword.kw list. Import keyword.kw list false, none, true, and as asset async. Link length keyword kw list. If you need to know more about a keyword or need to work with keywords in a programmatic way, then Python provides this documentation and tooling for you. Python keywords and their uses. The sections below organize the Python keywords in groups based on their usage. For example, the first group is all the keywords that are used as values, and the second group is the keywords that are used as operators. These groupings will help you better understand how keywords are used and provide a nice way to organize the long list of Python keywords. There are few terms used in this sections below that may be new to you. They are defined here and you should be aware of meaning before proceeding. Truthiness refers to the Boolean evaluation of a value, and truthiness of a value indicates whether the value is truthy or false. Truthy means any value that evaluates to true in the Boolean context. Boolean context. To determine if a value is truthy, pass it as an argument to bool. If it returns true, then the value is truthy. Examples of truthy values are non-empty strings and any numbers that aren't zero, non-empty lists, and many more. Falsy means any value that evaluates to false in the Boolean context. To determine if a value is falsy, pass it as the argument to bool. If it returns false, then the value is falsy. Examples of falsy value are 0 and set. Value keywords. There are three Python keywords that are used as values. These values are singleton values, can be used over and over again and always reference that the exact same object. You will most likely see and use these values a lot. The Python keyword false is similar to the true keyword, but with the opposite Boolean value of false. The Python keywords true and false can be assigned to variables and compared to directly. X equals to true, X is true, true. Y is false, Y is false, Y equals to false, Y is false, true. Most values in Python will evaluate to true, pass to bool. There are only a few values in Python that will execute to false when passed to bool. To name a few, passing a value to bool indicates the value's truthiness or the equivalent Boolean value. You can compare a value's truthiness to true or false by passing the value to bool. This is truthy value, X is true. Then it executes the false, bool X is true. Y equals to this is false, Y is false. Bool of Y is false, then it executes true. Notice that comparing a truthy value directly to true or false using is doesn't work. You should directly compare a value to true or false only if you want to know whether it is actually the value is true or false. When writing conditional statements that are based on the truthiness of a value, you should not compare directly to true or false. You can rely on Python to do the truthiness check-in conditionals for you. X equals to, this is a truthy value. If X is true, don't do this. Print X is true. If X, do this. Print X is truthy. X is truthy. Operator keywords and or not in this. Several Python keywords are used as operators in other programming languages. These operators use symbols like and or not. The Python operators for these are all keywords. Math operator and we can see here or not contains identity. These are the operators in operator keywords in Python. The and keyword. The Python keyword and is used to determine if both the left and right operands are truthy or falsy. If both operands are truthy, then the result will be truthy. If one is falsy, then the result will be falsy. Python x per 1 and x per 2. Note that the results of an and statement will not necessarily be true or false. This is because of the behavior of and rather than evaluating the operands to their boolean values and simply returns x per 1. If it is false or else it returns x per 2, the results of an and statement could be passed to bool to get the explicit true or false value, or they could be used in a conditional if statement. If you wanted to define an expression that did the same thing as an and expression, but without using the and keyword, then you could use the Python ternary operator. Python left if not left else right. The above statement will produce the same result as left and right because and returns the first operand if it's false and otherwise returns the last operand. You can also use an in an assignment x equals to y and z. If y is false, then this would result in x being assigned the value of y, otherwise would be assigned the value of z. However, this makes for confusing code. A more verbose and clear alternative would be x equals to y, if not y, else z. This code is longer, but it more clearly indicates what you're trying to accomplish. Thank you.